Hello and welcome once again on the lecture series Elements of Machine Design. Myself Mr. S.S. Mari, Head of the Mechanical Engineering Department. We are now in the lecture number 10 of course Elements of Machine Design. In last lecture we have seen regarding the standard code, the process of standardization, what are the different standards that are used in mechanical engineering design, and what are the benefits of standardization. Now we will move further. In this lecture we will discuss regarding the designation of steel, how the steels are designated on the basis of mechanical properties and on the basis of chemical properties, that is on the basis of mechanical composition and on the basis of chemical composition. So let's have the method of designation. Before going into the designation of steel, it is necessary to understand what is meant by the designation. Why it is necessary to designate a steel. Now in simple language, a designation means to give an identity to a particular element, to give a noun to a particular element, to give an identification criteria for a particular element is nothing but the designation. Means if I want to select a particular, say, cast iron or steel, then I should know what is the designation of that steel. From that designation, from that nomenclature, we will get an idea regarding the mechanical properties and chemical composition of that particular cast iron or steel. If a design engineer knows this, what is the mechanical property of that particular steel, what is the chemical composition of that steel, what is the type of that steel, then he can easily choose that steel for a particular application. So in simple language, a designation is nothing but a giving an nomenclature, giving an identity to a particular cast iron or steel on the basis of its mechanical properties and chemical composition. This is known as the designation. You have already studied the steel and cast iron in mechanical engineering materials. We also studied the classification of metals. So we will just brush your knowledge. What is meant by steel? In simple language, a steel is nothing but an alloy of iron and carbon. It is an alloy. Alloy means any component which can be made or manufactured by combining two elements. So it is an alloy of iron and carbon. Means steel contains iron as a base element and carbon as a base element. But the necessary condition is that with carbon content up to maximum 1.5%. If carbon content exceed above 1.5%, then it will turn into the cast iron. So we can say if any element or material contains a composition of iron and carbon in which the percentage of carbon is up to 1.5%, then we can say this element is a steel. Now, as we have studied the different types of standards in last lecture, that is in the lecture number 9, according to Indian standards, IS codes, Indian standard 1672, which is established in 1974, the steels are designated on the basis of two criteria. First is on the basis of mechanical properties and on the basis of chemical composition. So according to this criteria, the steels are designated. Now we will go through the different types of steels, say mild steel, tool steel, high speed steel, high carbon steel. So start with the mild steel. Now in case of mild steel, the percentage of carbon is up to 0.3%. If any steel contains a percentage of carbon up to say 0.3 to 0.4%, then we can categorize that steel into the mild steel. Once again, a steel is nothing but an alloy of iron and carbon. Now let's see how the mild steel is designated on the basis of mechanical property. Now this designation is carried out as per this standard, that is IS 1570. These steels are designated by a symbol Fe or FEE depending upon whether the steel has been specified on the basis of minimum tensile strength or yield strength. This is most important. The steel is designated on the basis of these two criteria, that is the minimum tensile strength and yield strength. And depending upon whether that steel is designated on the basis of minimum tensile strength or yield strength, we can write a symbol as Fe or FEE, followed by the number indicating or figure indicating minimum tensile strength or yield strength in Newton per mm square. It is square Newton per mm square. So take the example. Now in this case it is mentioned as Fe 290. Fe 290. If we are mentioning a symbol as Fe before any figure or number, that means this steel is designated on the basis of minimum tensile strength. If the steel is designated on the basis of minimum tensile strength, then we can write Fe as a symbol, and this number, that figure indicating this number, indicates that this steel is having a minimum tensile strength of 290 Newton per mm square. Keep in mind 290 Newton per mm square, not Newton per meter square. It is 290 Newton per mm square. Means Fe stands for minimum tensile strength and 290 stands for strength, that is minimum tensile strength in Newton per mm square. Now take the another example. Here symbol used is Fe and number is 220. Now if we are using FEE as a symbol, then this steel is designated on the basis of yield strength, and this figure indicates its yield strength. This figure indicates its minimum tensile strength. Means in simple language, if we are designating a mild steel on the basis of mechanical properties, then if that mild steel is designated on the basis of minimum tensile strength, then we can use a symbol Fe. If that steel is designated on the basis of yield strength, then we can write a symbol FEE. The number following that symbol indicates its strength, whether it is a minimum tensile strength or whether it is a yield strength. Minimum tensile strength or yield strength. Once again, Fe stands for minimum tensile strength, FEE is used for minimum yield strength. Both tensile strength is having unit Newton per mm square. Keep in mind, this is important. It is always specified in terms of Newton per mm square. So this is the designation of steel, or say mild steel, on the basis of mechanical properties. Now let's move to another criteria, that is designation of mild steel on the basis of chemical composition, or we can say a designation of steel on the basis of chemical composition. Now again, it is also designated on the basis of this Indian standard 1570. As we have discussed in Indian standards, on the basis of mechanical composition we are using IS 1570 as a standard. Let's see what is the procedure for the designation of mild steel on the basis of chemical composition. In previous slide we have studied the designation of mild steel on the basis of mechanical composition or mechanical properties. In this slide we will understood how to designate a steel on the basis of chemical composition. What is the procedure? First figure indicates 100 times the average percentage of carbon content. Keep in mind, if you are designating steel on the basis of chemical composition, the first number which is denoted there, the first number which is written there indicates 100 times the percentage of carbon. Always keep in mind, it is a percentage of carbon. Always it is a percentage of carbon and it is 100 times. Now this number is followed by a letter C. The C stands for carbon. That's why it is a percentage of carbon. And after C, the number indicates 10 times the average percentage of manganese. First number indicates 100 times the percentage of carbon content. After that there is a letter C, stands for carbon, and after C the number indicates the percentage of manganese. Let's see example. Now it is a mild steel, 20C8 is a mild steel. It is the designation of a mild steel. What is the meaning of this? Now according to this procedure, this 20 indicates 100 times the average percentage of carbon content. Means we have to divide this 20 by 100 because it is 100 times the average percentage of carbon content. Means we have to divide this 20 by 100, means actual percentage of carbon is 0.2 percentage of carbon. Keep in mind, the first figure indicates 100 times the average percentage of carbon content. That means we have to divide this first figure 20 by 100, which gives the actual carbon content, that is 0.2. Afterwards it is followed by letter C. It is followed by letter C, and after C this number indicates 10 times the average percentage of manganese. Keep in mind, it always indicates the percentage of manganese. Means we have to divide this 8 by 10. We get 0.8 percentage of manganese. Again see this example, 35C4. Divide this 35 by 100. We get 0.35. This C stand for carbon. Divide this 4 by 10, 0.4. This number stands for manganese. Means we can read as, if this is the steel, then we can read or we can get the information, a mild steel or carbon steel containing 0.35 percentage of carbon and 0.4 percentage of manganese. Here carbon steel or mild steel containing 0.2 percentage of carbon and 0.8 percentage of manganese. Divide first figure by 100, letter C for carbon, and divide last figure by 10, which indicates manganese. This is the basis for designation of mild steel on the basis of chemical composition. In previous slide we have seen how the mild steel are designated on the basis of mechanical properties. In this slide we have seen how the mild steel are designated on the basis of chemical composition. Now this is regarding mild steel. Now next type of steel is the free cutting steels. In last two slides we have seen the designation of mild steel on the basis of mechanical properties and chemical composition. Now next type of steel is the free cutting steel. Now these free cutting steels are designated on the basis of chemical composition. Note down, only mild steels are designated on the basis of mechanical properties and chemical composition, but from this onwards remaining type of steels are only designated on the basis of chemical composition. Mild steel is designated on the basis of mechanical properties and chemical composition, but from these steel onwards, apart from mild steel, all other steels are designated on the basis of chemical composition. So next steel is the free cutting steel. In simple language, a free cutting steels contains sulfur and phosphorus. Now if we add sulfur and phosphorus in mild steel, then that steel will become free cutting steel. Means these are the two alloying elements. Sulfur and phosphorus are alloying elements. Already you have studied what is meant by the alloying elements and what is the effect of adding alloying elements on the properties of mild steel. Alloying elements are nothing but different elements which are added in steel to improve its properties. That is known as the alloying elements. Now free cutting steel is nothing but a mild steel, but we have added sulfur and phosphorus in mild steel to improve its properties. That's why it becomes free cutting steel. Now these steel have higher sulfur content than other carbon steels, means mild steels. And now these free cutting steels are designated according to Indian standard 1570. As we know that each and every steel is designated on the basis of Indian standards, in the same way free cutting steels also designated on the basis of Indian standard 1570. So what is the procedure of designation of free cutting steels? In last slide we have seen how the mild steels are designated on the basis of chemical composition. In the same way we have to see how the free cutting steels are designated on the basis of chemical composition. Keep in mind, only mild steels are designated on the basis of mechanical properties, but all other steels apart from mild steels are designated on the basis of chemical composition. So the procedure for designation of free cutting steels on the basis of chemical composition is: first figure indicates 100 times the average percentage of carbon, as it is in mild steel also. The first number indicates 100 times the average percentage of carbon. Now this number or this figure is followed by a letter, capital letter C, which stands for carbon content. Then after C there is another number 10, as we have already seen in mild steel, that is 10 times it is a percentage of manganese. Means up to this point it is the same procedure as mild steel. Means the first number indicates 100 times percentage of carbon content, 100 times. This number is followed by a capital letter C, which stands for element carbon. After C the number is 10, that number indicates 10 times the average percentage of manganese. Means up to this point we get the same procedure which is followed in the mild steels. Now after this there is another symbol S, which stands for sulfur. This finger indicates 100 times the average content of sulfur. Not always there is a symbol of S. If instead of sulfur lead is added to make the steels free cutting, then symbol Pb may be used. Means if sulfur is used, then we can write S, capital S for sulfur, and if lead is used in this steels, free cutting steels, then you will get the symbol Pb, its nomenclature. Means take the example 10C8 S10, means if you see there S or Pb, then you can know that this is a free cutting steel. If only this portion is there up to 10C8, means it is a mild steel or carbon steel. Now how it is designated? Now this 10 stands for 100 times average content of carbon. This C stands for carbon. This 8 stands for 10 times the average percentage of manganese. This S stands for sulfur. And this again 10 stands for 100 times the average content of sulfur. Means we can read or we can designate this steel as, we can get the information that this is a free cutting steel. Its meaning is it is a free cutting steel containing 10 divided by 100, 0.1 percentage of carbon, C for carbon, 8 divided by 10, it indicates manganese, sulfur, and 10 divided by 100, 0.01 percentage of sulfur. So its meaning is a free cutting steel containing 0.1 percentage of carbon, 0.8 percentage of manganese, and 0.01 percentage of sulfur. So this is regarding the free cutting steel, how the free cutting steels are designated. Now take another example. C10 S18, 40 divided by 100, 0.4 percentage of carbon, C stand for carbon, 10 divided by 10, 1 percentage of manganese, and 18 divided by 100, 0.18 percentage of sulfur. Again here 10 divided by 100, here 0.1 percentage, not 0 percentage, it's 0.1 percentage of sulfur. So if there is a symbol sulfur or lead, then we can say it is a free cutting steel. Keep in mind. So this is regarding the free cutting steel. Next is the low and medium alloy steel. How the low and medium alloy steels are designated on the basis of chemical composition. Up to this point we have seen how the mild steels are designated on the basis of chemical composition, how free cutting steels are designated on the basis of chemical composition. Now we will see how low and medium alloy steels. Again, alloy steels are nothing but mild steel in which different alloying elements like chromium, cobalt, nickel, vanadium, tungsten, titanium, sulfur, nickel, phosphorus are added to improve its properties. These steels are known as the alloy steels. Let's see the procedure how low and medium alloy steels are designated on the basis of chemical composition. The first figure indicates 100 times the average percentage of carbon, as we have seen in case of mild steel as well as free cutting steel. Now alloy steels are the steels in which different alloying elements are added. Now these are the alloying elements which are added in mild steel to improve its properties. That's why these are known as the alloy steels. And each alloying element is having different multiplication factor. Now these alloying elements having these multiplication factors. we will see what is meant by the multiplying factor. If you will get any one of them as an alloying element in mild steel, then the multiplying factor is 4. If you will get any alloying elements from this, then the multiplying factor is 10. And if you get any alloying elements from this, then the multiplying factor is 100. Hence you have to remain this multiplying factor. You have to by heart these multiplying factors for different types of the alloying elements. Let's see how the alloying steels are designated. Take the example of 40Cr4MO2. Keep in mind, if apart from carbon, if the steel is mentioned or designated, then you come to know it is an alloying steel, because chromium and molybdenum are alloying elements, manganese is an alloying element, molybdenum is an alloying element, nickel is alloying element. From this you come to know it is a alloying steel. Now, though there is no symbol of carbon, but according to this, first number indicates 100 times the average percentage of carbon. Though there is no letter C is mentioned there, but first number always gives an idea about 100 times the average percentage of carbon. Keep in mind. Let's say example. Take the example of 40Cr4MO2. Now according to the procedure, 40 is the 100 times the average percentage of carbon. Means this 40 divided by 100, you will get 0.4 percentage of carbon. Next alloying element is chromium. Now the multiplying factor for chromium is 4. Multiplying factor for chromium is 4. Means we have to divide this 4 by this multiplying factor, because this number is actually after multiplication. 4 into 1 is equal to 4. Means after multiplying you have got this figure. That's why we have to divide this figure. That's why we have to divide this. That's why we have to divide this by this multiplying factor. Means 4 divided by 4, 1 percentage of chromium. Again next alloying element is molybdenum. Means where again the multiplying factor for molybdenum is 10. So we have to divide this by 10. Means 2 divided by 10, 0.2 percentage of molybdenum. This letter is stand for chromium percentage. This letter is stand for molybdenum. Now as the multiplying factor for chromium is 4, so we have to divide this by 4, and for molybdenum multiplying factor is 10, so we have to divide this 2 by 10. Let's say another example, 35MN2MO28. Now Mn stands for manganese, Mo stands for molybdenum. Now this first figure indicates average percentage of carbon, 100 times average percentage of carbon. Means you have to divide this 35 by 100, you will get 0.35 percentage of carbon, 0.35 percentage of carbon. Next figure is manganese. Now the multiplying factor for manganese is 4. So we have to divide this 2 by 4. We will get 0.5 percentage of manganese. There should be a manganese, not chromium. It is a manganese. 0.5 percentage of manganese. Molybdenum. For molybdenum multiplying factor is 10. So we have to divide this 28 by 10. So 2.8 percentage of molybdenum. Next take another example, 40Ni3. Means if you get any Cr, Mo, L, Pb, nickel, molybdenum, vanadium, then you will come to know it is an alloy steel. Take the example of 40Ni3. 40 divided by 100, percentage of carbon, 0.4 percentage of carbon. Nickel, the multiplying factor for nickel is multiplying factor for nickel is 4. So we have to divide this 3 by 4. We will get 0.75% of nickel. In this way, the low and medium alloy steels are designated. So in this lecture we have seen how the mild steels are designated on the basis of mechanical properties, how the mild steels are designated on the basis of chemical composition, how the free cutting steels are designated on the basis of chemical composition, and how low and medium alloy steels are designated on the basis of chemical composition. I hope you have understood how the designation is carried out regarding the steels. Thank you.